Assalamualaikum and welcome everyone. Thank you for joining us for today's webinar for Industrial Seminar and Profession course for first year Chemical Engineering undergrad student. My name is Dr. Shada and I'll be your host for today. So today we are presenting Microplastic Heterogenous in Malaysian environment, from identifying pollutant to designing practical solution, presented by Dr. Wan Muhammad Afiq, Wan Muhammad Khalik. Just a little housekeeping before we get started. If you have any question during the talk, please type them into the chat box and I'll bring them up at the end of the presentation. So this is a subject in which we should all be deeply interested because we all know that the implications of microplastic are far more serious and pervasive than we could ever have imagined. It turns out our behavior itself and also our lifestyle have contributed to the microplastic pollution, which affects on both health and environment. Therefore, by proposing innovative solutions, hopefully we could alleviate the microplastic pollution problem. So our speaker today, Dr. Wan Muhammad Afiq, is a senior lecturer at Faculty of Science and Marine Environment, Universiti Malaysia, Terengganu. He is a renowned principal investigator in his research field, where he develops the microanalytical method for detecting contaminants of emerging concern in environmental water under Microplastic Research Interest Group at UMT and the Center for Water Research and Analysis at UKM. He is also a member of several professional bodies, not to mention that he has experience as an executive editor for the Malaysian Journal of Analytical Sciences and has won several awards for his research outcomes. So before we start our talk with Dr. Afiq, please scan the QR code for the attendance for the ISP students. For other than ISP students, the link for the attendance will be provided at the end of the webinar. So now, without further ado, we will turn the stage to Dr. Wan Muhammad Afiq.
Assalamualaikum and good afternoon. Thank you so much, Dr. Shahada, moderator for this session. And very proud, a very good introduction on my academic career. And also, I feel very lucky today having this session with chemical engineering student and University Technology Malaysia. So perhaps that all invitation and also sharing session today will be give more benefits on your study, and also give the ice breaking to understand the history and what's so important of microplastic study in the Malaysia. So the titles given here is about the microplastic heterogeneous in Malaysian environment, from the identifying pollutant to designing practical solution. So ideally, it's a combination of multidisciplinary study, which is come from the environmental scientists who doing the mapping process, and also combination with the scientists like engineer who developing the system for the solution. So perhaps that the idea or the main point delivered here will give a new spark or the new idea to all researcher, to all students attend this session, and give a good opportunity for the collaboration between UMT and also UTM. So for my talk today, I will divide in four major compartment, which is let's start with the idea. What's it all about of microplastic? And second part, we go to the to know more in detail about our group, called as a Microplastic Research Interest Group established in UMT. And then the third one, I will be deliver to you the example of research has been conducted in perspective of Malaysian environment, and also we would like to share with you a few examples of corporate social responsibility conduct by our group as a part of a knowledge transfer from scientists to community. So this section hopefully will give a more interest about microplastic study. So I believe even though the majority participant here from undergraduate, but it's a good start to know about the situation in the Malaysia, as well as what the research get, what's the opportunity, what's the point out that can be sharing together between me and you and also other scientists. Uh, some of you may be familiar with the term of plastic. I believe everyone here, at least once in your daily life, consume a plastic as a container, as a wrapper, as all the function, which is we believe that plastic itself is very useful in our daily life. And let us move to the next terminology, microplastic. What does mean of microplastic? What's the all about? What's the main explanation of microplastic? Why is so important? If you're familiar with the plastic, so you should also familiar with the microplastic, because microplastic is the process of fragmentation. Microplastic is a plastic in the size of micro level. And microplastic, if you are not familiar, or maybe you not deal directly with the microplastic, but you may have experience using microbead in the cosmetic, especially for the ladies, or maybe we use a microbead in the presence of a toothpaste, which is designedly sized already in the micro size. So the issue of microplastic in environment is about, number one, we're talking about mismanagement of solid waste in our system. And like it or not, we must agree that amount of plastic production and also consumption year by year was increasing. And with the very numerous benefit of plastic, we cannot deny plastic itself give many useful benefit. But if plastic itself was self-claimed or popularly known as a single use of plastic, which is one times applied or one times consumed and then we throw as a waste. So mismanage of plastic will be lead to the formation of microplastic in the bigger scale. Plastic at the larger size, which is commonly known as a macroplastic, easily observed through the naked eyes, which is we can see daily. This is a plastic material and so on. Second one is a fragmentation of macro. We go to the next stage called mesoplastic. On the mesoplastic, they're still easily to observe under naked eyes, but the process continuing until plastic itself become mineralized, which is back to the uh, basic element is like carbon, hydrogen, and so on. But to reach from macro size to mineralized stages, it will take around 50 to 1,000 years. So if you throw a plastic today, yet maybe you not have a time to see the material become mineralized. So the process are continuing from macro to meso to micro, and even now scientists know about the presence of nanoplastic in our environment. The process of fragmentation or breakdown, microplastic can be triggered uh, through the physical impact, or we know as a mechanical impact, like heat by wave, heat by the hard material, so rock and so on, and also undergo through the chemical process like breaking the cleavage bonding between carbon to hydrogen through the presence of UV radiation, thermal radiation, oxidation, and even role by bacteria under biological degradation. This process will be take time, like I mentioned before, and before it go to the mineralized stage, it also already or possibly has been taken by living organism. Talking about living organism, it may subjected to marine aquatic organism or freshwater aquatic organism. Talking again about the food chain evolved in our ecosystem. So starting from primary producer, go to the feeder and until human as end consumer. And the issue about microplastic when human as end of consumer will be receive direct and indirect impact. And the image shown here is about the process or the possibility of microplastic generate in the environment. And through this process, it can be triggered to human directly through the intake, food source, or through the inhalation, through the airborne, or even through the dermal contact, which is having contact on the skin, and other possible route uh, go to the end consumer like human. And more difficult or biggest challenge on the study of microplastic because this kind of pollutant will not able to see through the naked eyes. You need the instrument or microscope approach or microscopy technique method and also chemical method to identify the presence of microplastic. And again, the interested part to understand of microplastic or also we can say as a challenge when microplastic existing at the macro level will be appear on the different physically and chemically on low level size. And the process will be continue as long as we not change the human behavior management system, how we manage the plastic consumption and waste. Because the process will be continuing. So it's not fair if I say, oh, okay, because of this problem, let's stop using plastic, change everything to non-plastic material. This issue will not solve immediately overnight. We need to think, as your scientist, we need to think problem is a problem. We try to handle, we try to design a solution based on the knowledge that we have from the problem. And problem itself, we need to have a short-term solution, long-term solution, which is hopefully to enhance the sustainability agenda, not only global, but in our beloved country, Malaysia. So become more interesting when scientists keep what we call point out the presence of microplastic close to our daily life. It started with the finding research by scientists found the presence of microplastic from stool, or easy to understand, is from human poop. Means the possibility at the first stage it probably come from ingestion, which is come from food source. And for the next one, scientists from other country, from other research university, figure out not only from the stool but major component in human anatomy. Microplastic has been found in blood. Microplastic even has been found in woman breast milk, and microplastic has been found in placenta baby. And of course, there's a lot of research figure out the presence of microplastic in food source. So as a human or specific, you working as a scientist or engineer, we must figure out why means we put as question mark a main problem and what's next. which is we try to figure out the possibility to overcome this problem. Like I mentioned, the process was triggered by many factors: chemical process, physical process, and also biological process. And we cannot say that, oh, okay, because naturally bacteria can be play role as degradator, which is reduce the size of microplastic until mineralized. The process is a slow, it's a take time, and then the amount, the massive amount of microplastic keep introducing on environment, and every day is a scientist reporting, which is mapping the presence of microplastic in river water, marine lake, from biota, fish, crab, prawn, mussel, and so on. So we still depending on this kind of food source of aquatic organism and other factor, and this one lead to importance of a study of microplastic. And again, this process still complex to understand because there will be have a variation, especially different types of polymer existing during formation of plastic. So in industry, we have a lot of plastic, maybe range from one types of plastic, a combination of polymer, which is hybrid polymer, make it more useful and make it more powerful with the purposes of uh, uh, production of manufacturing. Why microplastic is now important, especially in our environment? In fact, our study started in 2014, which is at the time our group called Microplastic Research Interest Group, or we know as MRIG, started with the idea because of uh, international publication. The first idea come up when scientists are reporting that Malaysia was ranked. During this paper published is since sorry during 2015 this article was published, and they are using data from solid waste management, which is specifically for mismanaged solid waste, and rank Malaysia was top 10. As a scientist, as a citizen, I believe you should respond. Is it true? Is it our country so polluted with plastic material? And they give a prediction, which is scientists give world total production of the formation of microplastic come up from the plastic waste is around 10,000 kiloton. And Malaysia itself will produce 370 maximum kiloton of microplastic. Based on prediction that this material will be continuing fragment, continuing breakdown, or become this from the larger size to smaller size, and more spark. Give the turning point that research should be started when it claimed not only Malaysia, you can see that country nearby, especially on the region of Southeast Asia, is a hot spot. What does mean? Means we contribute a lot of plastic waste to it to the environment. And in this study, they're talking about in specific marine environment. And if you see the facts, reporting means something not right on our environment. So it will be trigger more harmful effect on the aquatic system and more effect on our biota, ecology, biodiversity, especially on the organism health issue, and of course we will relate with human health issue on the end point. If we're talking about history, we're talking about the how it started. By facts, since 2009, research study on the plastic pollution is already available academically or scientifically reported in 2009. But during that time, the terminology more focused on plastic itself, means the plastic pollution regardless the types. So either meso, macro, or what else, this the main point to identify the presence of plastic itself. But you can see, uh, of course, the image that I show here is around 2019, but now we already 2022. It's already spark, it's already grow, it's already increased the number of publication. Every compartment, chemistry, biology, physics, engineer, try to understand this issue, try to adapt your field with this kind of situation, with this kind of hot environmental issue, and then try to contribute. For engineer, that you can play around, you can play the role, especially designing the solution. For the chemistry, maybe develop the method for identification of polymer set. So starting 2016 is the number of publication, the number of research microplastic in specific, we're talking about microplastic, was grow rapidly. So people start realize it's very important. And if you remember, the previous government highlight the campaign to reduce the single use of plastic. After that, scientists, researcher, engineer start build up the strategy to study to understand the microplastic issue in Malaysia. The process, I believe, will be continued because we still try to understand on the mapping stages, which is try to understand what happened in the field. This is a process what we call monitoring. We go to the river, we go to the lake, and then collect the sample from water, sediment, and other types of biota, and then we analyze to understand what kind of polymer, what kind of plastic found in a sample. So is it come from our activity in the terrestrial, on the land, or is directly impact on the marine issue or on the aquatic itself? So the process will be continued because I believe this topic is still yet to be saturated. They still have a many research opportunity to explore. As I was informed by your lecturer, Dr. Tengku, and also Shohada, you will be having a specific project to figure out the solution of microplastic issue. And I believe from this opportunity will be great start to understand the next process. Figure out about microplastic itself in Malaysia. We can see that locality itself doesn't reflect the novelty. What does mean? Means the issue, regardless the state. We cannot say, or maybe you say, oh, on the slide, Terengganu was polluted with microplastics. Sebab Terengganu having a lot of data reveal that microplastic presence there. No, because MRIG, Microplastic Research Interest Group, was set up in UMT. So we initiate the project, and of course we have more data in the Terengganu. But to be shared, the experience that we facing of during this period from 2016 until now is a really difficult to claim that, oh, this is a clean area, this is a polluted area, because the production of microplastic totally depends on what the activity involved nearby. And then the heterogeneous, what means heterogeneous? Means the diversion, the variation of microplastic itself was triggered out by activity, anthropogenic activity in the terrestrial. And our beloved country, you can see they have a variation of sample has been tested and they prove the presence of microplastic, regardless in the types of water, biota, from fresh water to marine water, all sample has been analyzed and show a diversion or variation of microplastic presence in our environment. Okay, go to the MRIG itself. So why I put up this information, because it's also important, especially when you try to figure out who scientists doing the research and what's the opportunity. Not only say, oh, okay, microplastic, so must be the scientist or researcher is come from the environmental scientists. No, we have a diversion. We have a different discipline come up together, forming a group and then think together, not only to identify the problem, also come up with a solution. So from now, I was appointed as a principal investigator, like a leader for this group. And we have Dr. Nolin, which is a work on the atmospheric chemistry. She doing more project on airborne pollution or airborne related with microplastic. And very, very interesting we found, especially a study microplastic indoor area. And the next one is Dr. Aliza. Dr. Aliza is a physical chemist specialized on the identification of polymer. We're talking about plastic. Plastic, the original material is polymer. Do you use single polymer or hybrid? So to identify, we need a chemist which can figure out the types of polymer presence in environment or the virgin or has been ages, which is long time period exposed to the environment. We have a Dr. Yusuf, which is Dr. Tengku contact before. Dr. Yusuf is taxonomist, marine biologist, which is work on the identification of microplastic impact on the biota. And again, it's a very important because on the mechanical system, on the engineer idea, sometimes you can get from the anatomy of biota. And we have a biotechnologist, Dr. K7, doing on the bacteria degradation. And again, I point out because on the biotechnology also can be embedded with engineering field. And we have Dr. Shahidi, which is neuroscientist, talking about the impact of microplastic on the human health, especially on the response of brain. And we have another one, a specialist on the biotechnology, but on the topic of aquaculture, Dr. Nur Asman. He's doing on the bioflux system for microplastic detection. And food technologist, Dr. Nizam, doing research on the presence of microplastic in food. So it's also we found very interesting, especially talking about the street food, makanan on the street, a food truck, what else, the example. So how microplastic through the airborne influence can be reached to our food. And we have Dr. Sabika working on biomaterial. This is a part of solution. It's also analytical chemist doing the possibility to replace the conventional of plastic to bio-based material, more environmental friendly. We have entomologists working as scientists who study the impact of microplastic ingest by insect. So insect itself is a good example on how microplastic can be break down into the smaller size. So this is a very interesting study to figure out, especially the nearby our household can be play role as a good agent for fragmentation of microplastic. Either it be safe after ingestion, so need further study. And we have a coral scientist, Dr. Jenny, doing the impact of microplastic on the coral health. And we have a Japanese scientist working on the UNT, the Shumpei. He also worked on the bacterial degradation on microplastic. And we have Professor Dr. Muhammad Fazil, is a ocean scientist and is a what we call a physical scientist doing research on the impact of microplastic distribution through the ocean system. And last 2 years is Dr. Ku and Dr. Maisara is environmental chemist, doing on the impact, Dr. Maisara, on the impact of microplastic uh, as a vector for the accumulation of metals, another toxic pollutant, and the precursor is also atmospheric uh, scientists doing the impact of microplastic, especially through the inhalation for the human impact. And the itself is an expert on statistics or chemometry. We depend on him a lot to when we have a lot of data for the analysis. Right. So this is ice breaking for the scientists. We have a lot collaboration because we believe that research or what we say, networking must be started because once you start a research, you need to gather more information and then try to understand the problem, not working as silo. So this is an example, just sharing with you a collaboration with the Japan and also industry like ALS Technical Camp located in Shah Alam, and also come up with the agency water quality from Nahri and also university international and also a national level and research institute. And thanks once again UTM bring us or invite us to give a sharing session, and I believe this is a good starter, not only because of sharing session, but we can brainstorming a lot of idea about microplastic study in Malaysia. Right. The next part, talking about microplastic research in UNT. I specific put it research in UNT because we have more information on what experimental work we designed before. Before we have a group, nowadays we have around 16 to 17 scientists together, which is specifically for UNT. And we have 22 collaboration outside, include university and research institution. But at the initial stage, we start with very basic to understand the presence of microplastic in environment, and we start the project with the marine because microplastic is a popular terminology through the term marine debris. So we start collect a sample from marine and then analyze. And second one, moving forward, not only marine, we should go to the freshwater as well because terrestrial impact come from connecting with the freshwater ecosystem, and we expand a lot, not limited to the marine and freshwater. We go to another major area, include sediment, water, biota and coral reef, biosymbiosis, and plastic degrading bacteria. And now we move up to the solution like developing biomaterial or design biomaterial, and also propose the analytical method which is more suitable for application in lab. And also more important to understand the impact or the fate of pollutant. What's the end of pollutant towards to the human health? We need to collaborate with the medical team. So in the next slide, I will share you our finding related with the human impact. Right. So this is one of the earliest research we figure out. Have you familiar with the name latest skull catcher? Maybe this is the first time that you heard. What if I say ikan siakap? Aha. And then it's come up the idea, oh, okay, ikan siakap tiga rasa, right? Three flavor of ikan siakap. So we collect two types of aquaculture. Number one is a cage culture, which is they are breed and then grow up in the cage, which is specially designed for the aquaculture. And we catch wild types of lettuce cariper. You can see that percentage of microplastic found in both almost similar, and make it more interesting when we figure out they have a variation of plastic color come up from black, white, blue, and so on. And each types of color give different percentage. So when we go in detail, we understand the black color not only come from the original color, but also because it's undergo the aging process. Once you collect the microplastic from the environment, you dissect, you cut to collect the gut of lettuce cariper, and then you digest using potassium hydroxide. This is this process, and then you analyze what's the plastic ingest. Why they ingest plastic? This issue was revealed by scientists when plastic was break down in the smaller size, and on the certain color, it make animal or organism seems more difficult to distinguish between uh, their food and also non-food material like the plastic. So especially the material like transparent. On the water column, it look like their food. So they will be mistakenly ingest. They take as food source and then it keep accumulate on their gut system. And this process become more dangerous if the plastic itself also serve as vector. What does mean? Vector means the place for other pollutant to attach. If you study on the science term, you may familiar with the hydrophobic and hydrophilic types. Plastic itself is a hydrophobic, which is not dissolved on the water, and other pollutant who hydrophobic also use uh, microplastic as their home or host to travel further than original place. This is an example that we found in the gut of lettuce character. And on the image on the left side here is a different thread like or fragment, fiber types. Okay, it should look like a thread seperti bentuk benang, and with a different color from green, black, transparent, and also orange. So you imagine if one fish collected and analyzed, you can find reach a thousand number of microplastic in their gut. So the process need undergo a microscopy. So this is a microscopy stages, which is after dissect and digest, we put under microscope and observe and collect one by one. You imagine how challenged or how difficult to identify, but yet still 50-50. So maybe plastic, maybe non-plastic, because if you look up under microscope, it may be like root of a plant. So they have an additional step or quality control step to confirm the presence of microplastic. Yet the physical observation under microscope is not enough. We need to go to the next stage called chemical identification. We bring the sample, go to FTIR, spectroscopy technique, or maybe go to the chromatography technique for pyrolysis study the byproduct, and then only the fragment, this is a spectra, match with the original. So we have a library, we have a virgin polymer. which is the new polymer, and then compact. So comparison here involve or must be exceed 75% match, and then that you can claim, oh, this is a polyamide. If you look at polyamide, one of the material come from the net using for the cage culture, and also other material come from fishing gear. And polyvinyl alcohol match, and you figure out what's the activity nearby using plastic based on polyvinyl alcohol. And the challenge to identify here, when microplastic undergo to the ecosystem or the environment, the pattern of polymer not longer similar with original one. So they have a breakdown. Sometimes the structure has been disturbed. So peak or spectra here may slightly different. So only if we can confirm 75% match, and then we can claim, oh, this is a material origin from polyamide. So this is how accurate and precise of scientists doing the research work. The next one, we move to water for. Oh, sorry. This one is a study on polychaete, marine worm cacing. Why it's so special? Because this kind of uh, species known as a keystone indicator for water pollution. So they need clean water for survival. So any possibility or any intervention of polymer, microplastic on the ecology has been traced or detected through this kind of organism. So we use estuarine polychaete called Namalicastis species in the skill wetland. Because in the Terengganu, we start and figure out the abundance of microplastic. Again, I mentioned to you, if you look at here, transparency was dominant. Because why? Transparency, when you enter to the ecosystem, it's more difficult and challenging to identify. Because this kind of color type is easily to uh, mistaken by organism. And for polychaete, this is a filter feeder. What does mean filter feeder? Filter feeder, it means they open the mouth and then take everything uh, through the water flow, food, non-food source, and then digest. And we figure out this also has been impacted by seasonal changes. What does mean? Means that the a cycle, a living cycle of polychaete insect was determined or impacted by the input introduced by terrestrial. Means more input introduced from terrestrial will give more possibility ingest by polychaete. This is an example. The polychaete itself, maybe if I do the comparison, if you see the terrestrial worm, the example worm, the size, so polychaete is 5 times or maybe 10 times smaller than the terrestrial marine worm. So with the tiny size, we also figure out high number of microplastic with a different color. So have a transparent, green, black, and also a blue. So the identification of color, we need to follow the international guideline or protocol. And of course, to figure out more on the surface changing, because we want to prove this microplastic is a not new intervention. It's not new introduced to the environment. So we go to detail like advanced microscopy technique, SEM, scanning electron microscopy, if you're familiar, and look up the different morphology changing. On the image of D, here you can see there's like a possibility attachment of biofilm, means the microorganism use surface of microplastic as a host for their survival. And if you see the image on the A and B, here is C, they have like scratch. Means the surface should be smooth, but now it's having a scratch on the surface, indicate have mechanical impact before. This example to prove the existing of microplastic uh, in marine water uh, with a different activity. First, we started with the Kuala Nerus. Kuala Nerus nearby in the Terengganu, nearby the UMT, located in Terengganu. And for this one, what we call activity, major activity come from local activity, which is like fishermen, fishing, and so on, and also small scale of urbanization and so on. For second location is port, the cruising area located in Kuantan, and the study specific to look out the impact of in and out shipping progress. And you can see here, there's also have a variation of microplastic found in both locations. And the value or the number of microplastic was sought out in three types: filament, fragment, and irregular. And you can see they have a variation in terms of numerical number of microplastic. Here is example, which is again we figure out through the physical identification. If previous one, you see more fragment of filament, on the filament types. Now here is example. This is like hard plastic, you crash, and then it's a break, become small size, kepingan-kepingan yang pecah. So this is under our waterways or water column. And imagine if this floating or dispersed in marine ecosystem and mistakenly ingested by organisms like fish and so on. Identification of microplastic was figured out, and we noticed the dominant was come out from polystyrene. When we're talking about polystyrene, you're always familiar with the material used for container, packaging, or other types of polystyrene material design. And also polyamide. Again, I mentioned the activity come from fishermen fishing, but I do not blame in specific, but the residue there, and then we can collect through the presence of microplastic in water column. If you say, oh, marine water, no problem, because we specifically we don't take the marine water as a drinking source. Now we prove the existing of microplastic in fresh water, which is by facts, fresh water was treated as a drinking water. And even if I'm mistaken, last week, the recent publication proved microplastic was found in bottle packaging, which is available in Malaysia. So it's a good point to figure out what kind of improvement we can use during the packaging or during the production of drinking water in the water. And in Sungai Dungun is considered smaller compared to Langat, compared to Klang, maybe compared to other big river available in Malaysia, but it's a proof also have a fluctuation, have a number of microplastic found in river. So imagine if small river like this can be impacted by the presence of microplastic, and those areas which is heavily urbanized development and so on, the chances become high. This is a number of microplastic found, and an example in the image you can see Sometimes we collect on the filament types, and also we found in the fragment, but the shape different from previous one. Under morphology, we observe, you can see on the SEM, it look like a rope, but it's already stretched. So it means indicate is undergo cracking process, mechanical. So it can continuing break down to the smaller size, and you can see on the image on B, they have a white spot here. When we observe, this indicate from filament or thread-like shape, they have attached the pieces of polystyrene uh, in between of surface microplastic, indicate the mixture or the variation of uh, microplastic exists in one location. And on D, a layer of biofilm surface of microplastic, showing that again microplastic exists as a hydrophobic material. It's a good for biofilm formation and also as a vector for other pollutant. The process is similar. Start with the physical identification, go to microscope, sort out, bring one by one, and then elucidate, go to the chemical process using FDAR, and then confirm. If you have more data, and then you do the statistical part to figure out which location the hotspot and so on. This is a very significant finding that figure out or find by our research group. We found microplastic in human colectomy. What does it mean? In the gut system. If previous one study on stool, which is the output, the final output, we try to study in the colectomy, which is the part where you absorb the benefit nutrient and so on. And our study with the collaboration with USM focus on the comparative study between patient having or suffer with a cancer and also normal. But more likely, it's difficult to get human sample in the health condition because it's about ethic, it's about rule, get the permission. So since we work with USM Kubang Kriya, and we get a sample from Kelantan. You can see here the characteristic of participant from female to male, from the diagnosis, which is the types of or the problem they are diagnosed from their history issue, and also sample. Microplastic found vary from 30 until 600 for one patient. So maybe myself itself, after living in this world 30 years old, so also have microplastic. But people will be questioning, I living for 60, 70 years, and I drink same water source with you. I take food source like orang-orang lama kan, makan garam dulu, talking about more exposure, but still survive. Yes, because microplastic or plastic itself is inert, which is not easily react for the any adaptation or changing. But we need to remind, we need always put in our mind that microplastic serve as a vector. What does mean? Mean as a host. So plastic itself maybe not give problem on our health, but the pollutant attached will be easily accumulated because it's already accumulated there, and then we consume as human, more easy to accumulate in the body. So the process, the fate still in progress. Scientists will be keep searching to understand this issue. So as an engineer, maybe we not put it our hand or our shoes in the perspective of medical, but you still can figure out the solution part. And here we have a very good paper on the explaining how marine microplastic, or per se is a microplastic, as a vector for major ocean pollutant, starting from metal, aromatic hydrocarbon, pharmaceutical, and how it's will be turning point end up to the human uh, system, human body system. The next part I would like to share with you talking about CSR program. As a scientist, any documentation or any scientific part that we publish in a high impact or high good journal will become useless if we not engage with the public. As a human, we must educate, especially young generation. Between me and you, a participant today, also from adult to young generation, and of course from you to kids, kindergarten, primary school, from abang, from brother, sister to young generation. So we start on 2019 to 2012, 2019 to 2020, one small project called Small Hand Change the World. So the activity, basically we get like declaration. Put your hand, which is colored with the paint and so on, as a promise to get good practices in daily life. So if we can minimize the consumption of plastic, yes, this. So we educate young generation, go to the school. This is an example where we go to SK Beladau in Terengganu. So we educate them, having a series of module and then having the fun-based activity. So we started with the awareness, and then what the solution. So the solution here, if they can do individually, so let's start individual action. And from individual, pass to the colleague, pass to the classmate, and then bring to the house. And perhaps we evaluate their human behavior, which is before activity, past activity, are they aware about the plastic pollution? So it's difficult to talk microplastic. Let's start with the bigger one, plastic. If we solve this problem, uh, automatic, or I can say that microplastic also will be show the good channel. Second one is second program is under called big impact. Small act, big impact. Same, but we adapt this activity with secondary school. On the first one, here is a first program under primary school, and this one is same. The small hand change the world. Small act, big impact. We improvise the module-based activity and implement fun-based activity or hands-on activity with the secondary school, and adapt them as teenagers. What action can be done individually, group, and community. So the series was conducted and involved a few community located in Terengganu. The next one, which is current activity, with the Team Green, keep it magically usable. And we adapt this program with teenagers, which is from Form 4, Form 5 until youth level, converting the waste, plastic waste. So our model system, or our model program, using the detergent container. Basically, you will throw after finish and then buy the new one. Or even practically, you buy the refill packaging. But we implement, because this is a part of activity, using this waste of plastic product turn to usable product. So we can use as a craft, use as a decoration for the garden and so on. We start our first module in this month, and we will be continue series of activity in following month. And ideally, this one not only implement from waste to product, but also from waste to wealth, which is you can use from the waste product and then turn to the income product. So very fun activity. So also we develop the program under eco brick. Eco brick means you collect all the single-use plastic, especially the plastic bag used for the shop or market and so on, and then you compress in the bottle, and then you design as a product. Maybe you make a table, chair, or any kind of miniature size, so we can use again as valuable product. To create awareness for adult, especially for the academic, for the scientists, and for the public, we also designed a called Microplastic Research Interest Group webinar series. This year we will start. Next year we will start again, because this event was started during COVID period. Because we try to engage with the public, not physically, so we meet visually, and we bring international and also national speaker from research industry, from university, and also from other institutions, talking about the same idea, the same problem, the same solution for the microplastic issue. And every student or participant here, I would like invite you. You can figure out one documentary. Is collaboration between DW. The DW is a document, what we call production team from Germany came to Terengganu and then shoot the issue of microplastic, which is led by our research group. Later on, maybe I can share with Dr. Tengku for you can see they have a short documentary, so they split in 5 video. So you can start with a video featuring Nas, this famous host, talking about how microplastic issue close to us in daily life, and what's the important to understand about microplastic issue, especially related with the food source. So it's available. Just figure out the DW documentary. Also point out or put a keyword microplastic in your food. And I would like to share this video was this documentary was announced as a winner in one of the documentary competition international. So very as a part of a team involved. So we are proud because they are bring this issue globally and make it more information was easy to deliver. And also we has featured in a few articles talking about microplastic, like Star and so on, and also have online portal. And the recent one was coverage from the France international media, talking about the issue of microplastic in Malaysia. So they have a podcast. So all the interview session was revealed or play on the radio France International. So if you're interested about microplastic and then interested to know more about my MRIG, so you can follow into social media, and we actively post at the activity, finding, publication, and also what current aim and all the related of microplastic through this Facebook. You can search on the Microplastic Research Interest Group UNT, or you can found through Instagram. So both was fully handled by our research team. So from that, I end my sharing session. So should I pass back to moderator?
So thank you, Dr. Wan Afiq, for the presentation, for a very interesting presentation. So now we will go ahead and take some time for questions. Just a reminder, please be sure to type your question into the question box in your control panel. So I'll go through some of the questions. Let's see whether we have questions or not.
Okay, thank you so much, Tiran. So if you're talking about the burning process can form microplastic, I believe it's still possible. So this is my personal opinion because I'm not come from the field of atmospheric. But more interesting, like I mentioned, we conduct the impact of or the presence of microplastic in indoor. It's small scale research work. We put it the probe for collecting the dust and also particle on the surface of membrane and analyze the possibility of microplastic. Yet, what we found is a number of microplastic exists in indoor was increasing with the presence of human or the abundance of human. Means for example, in the lecture room, when the lecture session was conducted, so student, lecturer was came and then do the activity. And the sample of microplastic generally came from our t-shirt itself because nowadays is a very famous the material called microfiber. So the new material and the each material both can be contribute or can contribute to the release of microfiber or microplastic in the environment. And more important, the level of exposure also depends on the ventilation system, either using uh, a fan, air conditioner, and so on. So if you're talking about outdoor, I believe there's more chances to get uh, microplastic in our environment, and even there has been proof microplastic existing in the airborne through the numerous research work. So I hope I respond the right answer to. All right. So the next one, how can we avoid from drinking water that contain microplastic? Okay, thank you for the question. If you're talking about microplastic per se, so to avoid that, we need to design the membrane system, which is filter the particulate in low size than microplastic, because microplastic was claimed or was classified plastic size less than 5 mm until 100 micro uh, size. So if you design the membrane for removal of microplastic in drinking water, especially we're talking about the treatment system, so you can pass. Need to bear in mind that microplastic is physical pollutant. What does mean? Means physically appearance different compared to chemical pollutant like metal, pharmaceutical residue, polyaromatic hydrocarbon. Those is a chemical pollutant and you identify as microgram per liter and so on, the unit. But for microplastic, is identified as item per liter or item per meter cube. For that one, is a good if you can propose a type of membrane. Our research group last time doing a research work where we try to understand, or we try to propose the membrane suitable to put it before water release from laundry, from washing machine. Because washing machine itself, when you do the laundry activity, is generate 1,000 number of microplastic per se, and more what we say, a new material was first time washed with an increased number of microplastic. So the each one is readily compact, produce less. So the same implication can use for drinking, especially on the treatment system. And in adaptation of this system, we need to put question mark. Are we ready to change the system to the new one? I give the right feedback to the key scene.
Okay, now we'll go for another question from Anik. Is that the question is, has there been any solution developed for the microplastic that exists in organism or our body?
All right. So for if you ask me about the fast solution, I would not say anything, because why? Because if we're talking about our body, we need to understand how the anatomy is working, and how the body itself is respond to microplastic. Like I mentioned, microplastic per se is inert material, which is polymer inert material. And for that case, what we're more concerned about the presence of microplastic giving impact or not co-current with other types of pollutant, like metal, toxic metal, mercury, for example, as an example. If attached on microplastic, we know that mercury per se is active element and toxic even at room temperature or at normal ambient level. So on that case, we need to understand the reducing number of uh, microplastic in the body system will be give same impact or not to other types of pollutant. And for solution for organism, certain what is it, biota used as a food source. For example, fish per se, we may remove the gut system. Kita tak makan the gut system, and we consume the flesh and so on. Maybe we can reduce part of impact on microplastic. But what happened to the organism that directly consume, for example, cockles or other types of bivalve, put on the plate, heat or grill, and then kena bakar kan, using that one. So we consume that one. So solution, like I mentioned, should be start how we manage the plastic itself. If we can reduce plastic waste systematically, indirectly or directly, we give more safer environment to microorganism as well as to human.
Next question from Hazim asks, so doctor, do you think maybe it's too late to prevent this from happening? Because for him, it says it's been widely spread.
Uh, to answering this one, I will more recommended to give my personal opinion. It's always put it better start now, rather than we say, oh, okay, everything automation has been done, just accept, and then we receive whatever. This is not a good mentality of scientists. We adapt, and then we can propose short-term and long-term solution. Like I mentioned, what action can be done individually? Let's start with the individual. So you use what the plastic cup. Can we replace with the uh, reusable plastic cup, which is can it be replaced in our daily life? Yes, start with the first action, and then we will keep more impact when everyone play their own role. Not only about microplastic. If we're talking about mental pollution in our environment, has been solved nowadays? No, but we try to adapt. This is a short-term solution. This is a long-term solution. So can we adapt this system? Yes. Can we implement to another area? Yes. So that one make our ecosystem sustain and then getting better help on the environment. So the question itself is very general. If I say late or everything, oh stop lah, no need to doing research, but let's start even the small action. Per se, you say, oh okay, this is small action. No, sometimes you believe small action, but the impact will be the next.
Next question would be, by the way, that one is, I think I agree with you where it's better if we do something rather than not doing anything. So Hisham asks, what is the role of student in order to reduce and annihilate microplastic?
Thank you, Hisham. For the question here, I would like to do amendment. What is the role of human? Because student, lecturer, or even kids, if you start a good practices, which is implement, I want to start. I love a coffee. You go to the what else? Any brand? I cannot say specific brand. You go to buy coffee and so start. Oh, okay, rather than using the one times plastic cup, can we propose more environmental friendly? If you student on the engineering base, if you start recycling
Oh, I think we are lacking. So while waiting for Dr. Afiq to come back, um, just a reminder that you can type your question in the question box. Or I think Dr. Afiq just got disconnected. Please be patient, and everyone. I'll try to get in contact with him.
sorry,
Welcome back,
sis.
Dr. Afiq.
Sorry.
No, that's okay.
Right.
Do anything with the connection, right? So we'll proceed with the Q&A session, yeah?
Yeah,
The next, yeah. Have you finished answering?
yeah. This one I'm already finished.
Yeah, so next question would be from Ahmad Arshad. He asks, does the number of vehicles on the road affect or contribute in the increasing in the amount of microplastic?
All right. For answering this question, if I'm not mistaken, they have a number, but still limited number of study to understand the impact on the roadside contribute to the microplastic. And make it more interesting here is about that how microplastic itself was traveled from the original. If you're talking about roadside, basically, or the road dust, you're talking about what's the activity nearby, closing to the study area, and then how possibility to travel from origin to the new destination. So per se, to understand that uh, on the microplastic, they are co-currents because for road dust or roadside study, another perspective is to understand is a micro rubber that existing from the movement of tire impact also to the our ecosystem or especially on the atmospheric part.
And then the next question would be, is there any advanced technology in Malaysia have been used to remove microplastic from WJ Cove? Oh, Dr. Afiq, I think you are on mute. Oh,
Okay, huh?
now
Can
it's
you?
okay. Can hear you.
Right. So if you're talking about advanced technology, the best or the practical solution we can propose is how we can design the system which is can track the microplastic either in the water system or another system which is relevant to the research work. And talking about technology developed here, you need to understand the properties of microplastic itself. If microplastic was want to cater on the part of physical appearance, so means we can design the membrane pore size smaller than. But once again, I would like highlight here, you may solve the issue of microplastic, but yet the plastic itself can continuing break down until nano. So still we can say that okay, solve at one stages, develop a membrane or any kind of material that can trap the system. But how the material was introduced to the wastewater treatment plant or the drinking system plant. So it's depending on the availability itself. And more recent technology also must be multi-purposes, which is not only cater the issue of microplastic, but can the same material using for extract or remove other kind of pollutant. So if we can design that one, will be a good. Not only for microplastic, I think we can also treat other kind of pollutant.
Understood. Then the next question would be IVL. Is Malaysia doing good in handling microplastic? And any example of one of the best actions taken that you personally agree to?
All right. Thank you for the question. If I put it on the big umbrella, or if I want to give the sharing about my experience, Malaysia having a progress, and since we have a specific ministry under CASA on the environment and specific on water, but if you say that this is a, should be solved by government, this is a wrong what we say perception. Even talking about plastic pollution, microplastic issue, everyone should be play role. Number one. Number two, the progress should be smart. Not only we talking about okay, solution, but yet we are lack in terms of fundamental. So like our group, even we go to like designing a solution. Myself try to cater the removal of polystyrene using ferrofluid method based on the magnetic we co-current. Maybe I can share. We're using the oil as waste from cooking and also from other types of lubricant, mix with the magnetite and then become the ferrofluid. So from ferrofluid, we treat the existing of polystyrene as a model. So from first step, we can propose to the public, we can propose to the scientist community as a small action but practical, so maybe can solve for that kind of level of problem. And but yet we still need to proceed with the mapping stages, because an early presentation I share to you, this is a presence of microplastic in Terengganu, in Pahang, in Kelang. What the rest? We need more data. So that's why every scientist, regardless their field, they can play role on every expertise, or every what we say counterpart. Uh, as a chemist, we do on the lab and then propose this method. And on engineer, design, engineering part in design or what else. So maybe I give the very general example because I'm not from the field. And also social scientists, they have a changing the human behaviors and so on. And then we keep doing this process. And uh, perhaps we can trigger out or boost this kind of research, make it more efficient, which is cover up in the many aspect on the fundamental part, the idea, the root source of problem, and also the solution. Because sorry to say, scientists, especially on the Malaysia, basically when we have a problem, oh, let's go to the solution, without understand the fundamental part first. So go to the fundamental part. I, in fact, the microplastic issue has been catered by European continental or scientists many years ago, and then they start with the mapping process, which is they figure out what's the types of polymer, what types of microplastic residue exist in the environment, and then come up with a solution.
Okay, and then this question, I think they are asking quite a similar question. So from Firhad, will it be flushed out by our body if we consume microplastic? Kor Yang Ho also kind of asked a similar question. Is it possible for microplastic to act as a carrier for pathogens or chemicals when they enter living organisms? And another one should be from Jorgen Thiran. Since the microplastic can be found in the blood, can it affect the body organs? How dangerous microplastics are? Oh, Dr. Afiq, I think you're on mute again. Oh, I still cannot hear you.
Hello?
Now can.
Right. So I don't know if it's automatic. It's a bit all right. So talking about the issue. So that's why I said when we have a sharing session like this, it's always you feel it's urgent or so important when we highlight related with the human issue. If I say, oh, okay, microplastic exists in the fish gut, found 5,000, it's okay, it's not related with us. But if you say, oh, in your body, in your blood, in your kidney, in your, for example, in your stool or in your skin, what else? Or become, oh, do I see from this kind of negative impact? So, talking about the consequence existing of microplastic in our body system, I cannot reveal in detail from now on, because the fate of microplastic in body system still under investigation or research. But proven by scientists that microplastic is continuing breakdown. So once they enter in the body system, the possibility to continuing breakdown becomes smaller size still available. And more important, when it's a continuing breakdown, the size becomes smaller and there's possibility to penetrate on the blood system. In the blood system was connected from hay to the feed, and we make it a good questionable. Means we try to understand more on this study how the existing of microplastic plus with other pollutant effect. So they're still under question mark, still under big question. If microplastic exists and other pollutant, like I mentioned, hydrophobic, I think the same information was stated in the question, can boost the issue like this is related with the cancer, this is related with other types of disease, or this is related with other types of what we say uh, symptom or phenomena, because nowadays in the health issue we have many issue related with, oh, this is a new symptom, this is new kind of cancer found, this is a new diagnosis found in the human health. So it came uh, still not really clear. I cannot say, oh, because if I claim, say, oh, this is doctor mentioned, oh, okay, microplastic because of cancer. No, it's not fair. So research was continuing, research was in progress. But what I can say, let's start with solve the plastic pollution on the anthropogenic activities first, and then from that we can really understand the impact of microplastic not only organism as well as on human health.
Next question would be from Shahmi. He asks, is there any solution for the fish from the ocean to be free from microplastic and be safely eaten for the human? Is there any initiative or solution on that problem?
All right. If you come up with a solution, it seems very difficult to. I said, okay, this is best solution. So is it practical or not? Because the practical solution here is what we can remediate, or means we can first recover, remediate, or we can prevent. I cannot control fish from the ocean. Okay, because the what we call feeding behavior or their living system in the aquatic is a the progress is naturally. So if we produce or if we contribute microplastic or plastic based on the ecosystem, they will be continuing mistakenly invest. You can say that, or you cannot educate. Okay, fish, this is your food. This is not your food. It's not possible. So it means if we avoid the non food source intervention on the ocean system, and the nature will be back to the normal. And more uh, practical solution to point out here that the action was started from us, means as human, you reduce one type of plastic, your friends, me, and all the participants here from Johor and continuing until worldwide, and then we can get a safer environment.
True. Oh, we have a question again from Hisham. Involvement of 3D printing is one of the goals of IR 4.0. However, 3D printing uses plastics and accumulate plastic waste too. Is this a big concern? Or that the 3D printers use biodegradable plastics?
All right. So it's a back to what I mentioned before. We can't deny the benefit of plastic. Every day, even our surrounding, the material to produce using plastic become cheaper. So it's a preferable on the production. We cannot blame, oh, because you make 3D printing material from plastic and then I using, so we blame the manufacturer. It's not fair because benefit is still there. But if scientists, if researcher can propose, for example, from the synthetic polymer, we change to biodegradable polymer. Biodegradable polymer sometimes can be extracted If you're familiar before, when the issue stop using plastic straw worldwide, try to replace using bamboo, using type of plant, using aluminium, is a good action. But how efficient the system was changed? Are you ready to use from plastic to aluminium, stainless steel, or non plastic material? If you're ready, myself ready, and everyone, is possible to change it. And any kind of material can be turned to environmental friendly. It's possible, but we always put the question to our mind: Are we ready to adapt the cost? Are we really ready with the material? For example, if I say the best solution using straw or using the 3D printing, make it practicable. The best material we replace using a bamboo as extract. You design the 3D printing rather than plastic using the bamboo. But how efficient to convert all the manufacture from 3D printing using the plastic to the bamboo types? Or say no, the amount, the production of bamboo or the growth or the crop of bamboo worldwide only 10%. You cut everything, finish bamboo, and then will be defect to the panda because it's a food source. And then you change, you give the negative consequence on the food change for the system. So that one create another problem. So adaptation from, for example, if we can change from synthetic to semi-synthetic, from semi-synthetic to green one, will be better. If the material is abundance or a massive production, you can change to environmental friendly. Yes, we can proceed that.
So next question is from Jai Yusai. Is there any legal cases regarding consumption of microplastic in Malaysia?
All right. From now on, as far as my concern, as far as on my best knowledge, there's not have a specific report on the microplastic. But if you're talking about the lethal cases of death issue for the microplastic, look at the bigger scope where the plastic pollution is at. You may familiar with the what we say plastic choking on the animal, like sea lion, or the straw stuck on the nose system or nasal system for the turtle. So this is example. So on the larger size, the already given this kind of problem. So you imagine when the size of plastic becomes smaller, so the surface area over the ratio is become bigger. So it's become more or high chances of using microplastic serve as host for different types of pollutant.
And then we have two questions that maybe Dr. Afiq can answer because it's quite similar. So question from Ari Varasuragu. Does the microplastic biodegradable? Another one would be how biodegradable plastic could effectively reduce microplastic waste.
Okay, if you're talking about does microplastic biodegradable, so if plastic itself is what we say synthetic polymer, is not biodegradable, and the properties itself may change after a long duration exposed in the environment. Second one, talking about how effective we need to measure the transition from synthetic to biodegradable. So means to measure the effectiveness maybe in terms of perception, in terms of consumption among consumer and so on. If we said, oh, change immediately effective. Yes, if you introduce biodegradable, but at the same time, number of plastic waste from the synthetic polymer or non-biodegradable material keep increasing, which is massive production, so will not solve the problem. So transition, or what we said, application, or the willingness of buyer to replace from biodegradable to sorry, from non-degradable to biodegradable should be measured. And you notice if material come out from biodegradable, the price is a little bit higher than commercial one.
And the next question would be animals and trees are always evolving to the change happen in the ecosystem. Thus, does animal have evolved so they can uptake less microplastic from feeding?
Okay, talking about adaptation is more accurate. We talk about adaptation of any organism and plant depends on the ecosystem change. But for the organism, either terrestrial or aquatic per se, the adaptation will be influenced on their living cycle. But the issue here we're talking about food change, either from plant to the animal. All the end consumer, we can say in the ecosystem change is related with the human. If the adaptation make it the gut system or the part of anatomy in animal and tree can absorb more. For example, if the plant adapt with the presence of microplastic residue, and then the accumulation high in the plant system, and then plant itself was consumed a human as a food source vegetable. So in the final impact on human, adaptation on animal organism or even plant maybe occurred, but we need to think further about the impact on human itself.
Now we have another two questions. They are related. One is from Muhammad Firhan. Will it be flushed out by our body if we consume microplastic? And the other one would be um, since the plastics are non-biodegradable, it should be flushed out from our system because many organisms are getting affected by this. So what do you think about this, Dr. One?
Okay, talking about flash or remaining, what make more interested, first thing is a proven it can flush out because scientists found in the stool or in human popes. The next question, if we consume, if I put numerical, let's say we consume 10 pieces of microplastic or 10 types of plastic and flush it to still have 20% remaining in body system. So where the plastic itself will be retained and what's consequent or effect on the human health? That's more important question. Flush out is adaptation to human system. Even you're talking about other types of pollutant, uh, metal, residue may exist on the food, like food source or on the drain system. We consume and then flush, but the excrete amount not necessarily balance what you consume. So we talk about what's impact on the remaining one. So that's more interesting. So if the percentage of microplastic or plastic higher retain then flush out, and I believe we will create more idea or create more question what's next will be happen.
The next question is from he asks, I believe the one I've heard of nanoplastic. How bad it will be for us if the statics of nanoplastic is the same as microplastics?
All right. The nanoplastic also has been engineered design. So if microplastic like microbead or any types of micro size of plastic design, same goes to nano. Uh, why scientists put it or highlight about micro size? Because the transition from micro to nano is a breakdown process or getting the smaller size. When the getting plastic getting smaller size, and then the surface area will be increasing, and then the possibility attachment of pollutant increase. The issue to understand bad or not using nanoplastic, I think will be give same answer if we figure out what's the consequence of microplastic itself in ecosystem, in human body, in the environment, or what else. So you can handling the microplastic issue, and you can cater the nano issue.
Next, from Ivan Young, is there a way to completely purify our drinking water from microplastics?
All right. So for purified water, drinking water, like I mentioned, plastic itself is a physical pollutant. If the manufacturer filtering system design on the size smaller than microplastic, so that I strongly believe that particle can be removed, or at least efficiently to reduce number of microplastic. And back to this question, if your drinking water adapt to the system, which is before you use as the final one, before you boiling, or if you or directly take from the dispense system, having the system with the filter design or filtering system, yes, that one is one of the prevention. But like I mentioned, you can figure out the study on Malaysia finding existing of bottle. So can you adapt or can you change the manufacturing stages? No. So to say that, oh, okay, this is the best solution, from now on I have no answer. But on our daily life, if you're using filtering system smaller than, which is uh, ideally is famous with nano filter and so on, is a good prevention for a block or avoid microplastic enter to a drinking system.
So Fui Yuan asks, other than Malaysia, is there any other countries also did a good role in controlling microplastic, and what's the solution?
Okay, talking about country, uh, controlling microplastic per se, I can say that maybe not exist the stages, but more effective is about the country efficient on the solid waste management. So you can go to the advanced, which is what we call negara maju, okay, adaptation of solid waste and how they treat the system and how they apply the 3R or 4R concept: reduce, recycle, what else. And this is a good example. So to say that is a good controlling microplastic, okay, microplastic itself, if you're talking about once it's entered to aquatic ecosystem, it's become borderless pollution. What else we throw, for example, in our river, go to the ocean, and ocean have a circulation, has a distribution through rule by wave system, and then reach to the for example, reach to the Indonesia. So do you claim, oh, okay, this is a waste that I threw before? Of course you didn't claim. And same goes to other country. They throw waste to the aquatic system and then reach to our country. And can we say, oh, this has come from country A, country B, country C? No, because it's readily become borderless pollution. So not only Malaysia, not only good country, advanced, modern, and so on, but every. So that's why issue about plastic and microplastic, many entities like United Nations, Westpac, West Asia Pacific countries, even Asian, try to adapt, try to sit together and then discuss. Oh, this is plastic pollution. How your country handle this one? How my country handle this one? And then we discuss a solution. It's involved many entities, many department, and also parties.
All right, now I think we are reaching 4 o'clock. We'll just take another one or two more questions from the audience. So, from Megat Farhan Daniel, he asked, may I know if microplastic can be reduced by accumulating it back as original? If possible, it may be one of alternative to help solve this issue worldwide.
I try my best to give feedback to this one, but it's quite what we say uh, difficult to adapt, because why? First thing first, need to understand. Let's say I give you one bottle, empty bottle, drinking water, plastic, and then let's throw to the ocean, and then the particle is the plastic itself just lay on the ocean, day by day, year by year, and so on. From one bottle, it break down, maybe become two pieces. From two pieces is multiple for 4, 16, and so on, until the production material itself become thousand pieces of microplastic. So with the different size, different shape, and so on, if you're talking about reducing by accumulating back as original, I believe not possible. But before it turned to microplastic, so avoid, which is like single-use plastic, avoid mismanage of material. So you can reduce the material itself, and then you reduce number of microplastic generated. In that case, it's more practical.
Right. I think that's the last question we'll take because oh, we have one more. Why can't we blend plastic?
Okay, this one seems like it's a very how to say, short, quick solution. This is a problem. Ban. This is a problem. Ban. If we ban everything, we deny the benefit of material. Like I mentioned, plastic itself, we cannot uh, blame it. Or plastic create so many impact on the organism, on the human. Ban, because it's a create. But like I mentioned, are you willing? Are you ready for the adaptation of alternative? If not, go to the short practical solution. How? Start with the reducing. If not able to use, not able to completely avoid, reduce the number. Change the practical. If you can drink without the straw, change the practical. Very easy. Avoid. Go to the. I believe if you go to the restaurant, sometimes it's awkward where you say, oh, okay, no straw, and then ask, why no straw? I said, for me, I don't need straw because I can drink directly from the cup. So one step I take daily in my life, and then my friends, my colleague, my research team, and everyone take, you can reduce. So when the production, sorry, when the consumption is reduced, do you think the production will be increased? Because demand is low, so the production will be low, and then you generate the situation where the dependency of straw now is reduced, and say, oh, okay, no, I have not reduced, but I replace. So another term of recycling. So I replace. Now, okay, let's say I have I have effort to use a non plastic material as a straw. Yes, I'm convinced that one. Everyone. And the alternative become a good production now, and the consumption will be increased, and then we change from step by step. But ban the material just because of, oh, okay, this ban. This is made different with cigarette. Cigarette harmful. Okay, ban because we don't find any kind of benefit from that. But plastic, I don't agree because still have a benefit. But we try to avoid, especially on the single use of plastic. I hope I answered the question.
All right. Sorry we cannot cover all of the questions from the audience. So before we wrap up, Dr. Wan, Mama Afiq, do you have anything else you wanted to cover?
Thank you, Dr. Shuhada. Just one last message to, like, take home message to everyone. In any position that you facing on, means student, lecturer, academic, scientist, or what else, let's start with the good deed for our ecosystem. So from that, we not only cover the problem root cause, but also we provide. So everyone have their own role to provide the solution. So good action also is a good solution for environment.
Okay, great. Thank you, everyone. We appreciate you being here. Thank you again, Dr. Afiq, for the informative and interesting talk. Hope to see you again in the future. Um, if no one would like to add anything or any announcements, I would just end our seminar today. Thank you again and have a very good day, everyone.